Hello, thank you so much for tuning into my YouTube channel. Today's video is going to be a simple tutorial on how to code a convolutional neural network from scratch and then apply it to an example problem. The example problem is going to be using that convolutional neural network to tell us the color of an object inside the image. The object is going to be a rectangle of random size and color that is inserted in a random place in the image. Let's get started and see how we could do that. As I said, this video is going to be a tutorial on coding a simple convolutional neural network from scratch on TensorFlow, which could tell us the color of the objects. In today's video, I'm going to build a very simple CNN from scratch that tries to tell the color of the rectangle that is inserted into a random place in the image. The size of the rectangle is also chosen randomly. This is a very simple problem, but the purpose of this video is to show you guys how to build a simple CNN from scratch in TensorFlow and apply it to an example problem. Here is the architecture of the CNN we are planning to code. So as you can see, the input to the network is an image that has a small colored rectangle, and the output is an image the same size as the input, but the whole image is colored with the same color as the rectangle in the input image. It should be noted that the area around the small rectangle is black. There are about 10,000 images in our training set, and the size of the images are 20 by 20. These are very small images, but it's going to be enough for the purpose of this video. And these small images are going to also help our network run faster. So as you can see, the network has 4 hidden layers, and the kernel size is always 3 by 3, and the stride is going to be also 1. So there's no compression and then decompression. But the number of features are going to first increase and then decrease to 3, which is going to be equal to the number of channels in our output. And as you can see, we are using ReLU activation function except for the last one, which is going to be sigmoid. Let's go to Python and see how we could code this CNN. Okay, here's the coding for the CNN that we're going to build. We first import the things we need like NumPy, IMShow, and also the components of CNN, and also the things we need to load the images. And as you come down, this is the folder that contains the input images. The input is going to be the images that contain a colored rectangle on a black background. So the size of the images are going to be 20 by 20. They're going to be normalized, and then the images are going to be appended to one another. So this images1 variable contains all the input images, which is going to be changed into an array and saved into X. The same thing we do with the output images, which are the images that have the same color as that small rectangle in the input images. They're all going to be appended to one another, and they're going to be saved as an array in Y. So we start building our network here. It's going to be sequential. The input shape is going to be set here. This is the first layer with 8 feature maps. This is the second layer with 16 feature maps. This is the third layer with 8 feature maps. And this is the last layer with 3 feature maps, which is going to be equal to the number of channels in our output. And this is where we compile our network. The optimizer is going to be RMSprop, and the loss function is going to be MSE, which is going to be good enough. The verbose is 1, which means that we're going to see the loss in each epoch. We're going to go through 500 epochs, and the batch size is going to be 80. This is where we are fitting the network. In other words, our input is going to be X and our output is going to be Y, and we're going to make the network learn to go from X to Y. We're also evaluating the network, and after that, after the training is done here, we go and test the network on our testing data set. To do that, I'm going to be applying the network only to one image to see what happens when we apply it to image. For the purpose of this video, testing the network on only one image is going to be enough, but for your network, you need to test it on more. So this is where I'm going to be reading the testing image, and I'm going to be normalizing it, and then I'm going to be changing it into array, and I'm going to be making it compatible with the input to the network through reshaping and other things. And this is where we're going to estimate the output of our testing image. And after that, we're going to reshape the output so that we could show it as an RGB image. And this is where we are showing the output. So before we run, let's see the input testing image. So this is the testing image that we're going to test the network on. As you can see, the small rectangle inside this 20 by 20 image is green. So we expect the output of the network to be totally green. Let's run the network and see the result. So the run is over, and as you can see, the result is what we were expecting. In other words, an image that is totally green in all areas. This was a very simple problem, but I just wanted you guys to see how we could build a CNN from scratch and apply it to our own problems. And that's about it. Thank you so much for watching this video. I hope you liked it and you were able to get something out of it. If you liked it, I would appreciate if you could subscribe to my channel and also share the video with your friends. Thank you so much and have a nice day.